Good morning, Trig. So I'm going to try to get this done pretty quickly. So 45.A is on conditional permutations. And permutations are looking at how many possible outcomes are possible. I've attached a blank one of these printouts so you could do this lesson along with me. So here is the first one. How many odd counting numbers can be formed from the digits 3, 4, and 5 if no repetition is permitted, meaning we can't have the same number over and over. Now, I've made a note here of what we know about odd and even, but sometimes we forget what we already know about subjects. So odd and even numbers are odd or even based on the last digit. For example, 374, even though these are odd, this is an even number because of the last digit. Okay, so odd and even numbers are based on the last digit. Okay, so 245 is odd because of the last digit 5. So I had already started this and realized I wasn't recording, so I apologize. So for this one, and you have one similar in homework, it's not telling us how many digits are in our odd number. It just said how many odd counting numbers. So I could have a single digit odd number like 1, 3, 5, 7, 9. Those are my odd single-digit numbers, and those are the only single-digit odd numbers. So if I have a single digit, I only have one place to put a number, and the only numbers I have from this list are the 3 and the 5. So I have 2 total possibilities for single-digit odd number. Okay, so I've written a note. On the bottom is my possible numbers. On the top is the total possibilities. 2-digit. So that would be an example of a 2-digit odd number, right, would be 11, 31, 25, 49, right? Those have 2 digits, and they're odd because of the last number. So because this is based on the last number, I'm going to do this digit first. Now, the only options I have are 3 and 5, so there are 2 that could go here. Now, if no repetition is permitted, then I only have 2 left here, right? It would either be in this spot, I could either put the 4 and the 3 or the 4 and the 5, depending on which one was used here. So I only have 2 possibilities here. If it helps, you could make a list of the actual 2-digit numbers that are possible. If I'm only using 3, 4, and 5, 35 is a possibility. 34 is not odd. 53, 45, and 43. 1, 2, 3, 4. That should match 2 times 2, which is 4. Okay? Bottom, 3-digit means I have 3 spaces. I'm multiplying. Now, I could only have, I'm going to start here first. I'm going to do this first because odd digits are based on the last number. And the only 2 odd numbers we have are 3 and 5. So I have 3 numbers, but let's say I've used one of them, so 2 could go here. And now I've used 2, so only 1 could go here. So this is also 4. So now I'm going to add these 3, 2 plus 4 plus 4. I have 10 total possible outcomes. Next one, find the number. Okay, let's go over important things. Odd, 3-digit counting numbers that are less than 600. Okay, so find the number of odd, remember, so that last number, last digit is odd. 3-digit means I have 1, 2, I have 3 places. Less than 600. So the largest number possible, is 599, right? That's the last number that would be that's the largest possible number. I'll go ahead and write. Is 599. And I'm not counting 2-digit and single-digit because they specify that there are 3 digits. So we're going to start with this spot first, right? Because odd numbers are based on the last digit. Okay, so this did not specify that I was limited, so I could put the number 1, 3, 5, 7, or 9 here. That's 1, 2, 3, 4. That's a total of 5 options. All 5 of those would make the number odd, like 599. It also doesn't mention that repetition isn't permitted. So then in this spot, so I can use the same number again. What could I put here? Well, I could put numbers 0 through 9 here. So I have 10 options here, right? Example, the number 409 is an example where you have 0, and it's still odd, and it still has 3 digits, okay? So then here, I cannot put 0 here. I can't put a 0 here because a 0 would mean I have nothing in that first place, and that would make it a 2-digit. So the only numbers that could go here are 1 through 9. No, the only numbers that could go here are 1 through 5 because it said less than 600. I cannot use 7 and 9, or sorry, I cannot use the numbers, cannot use 6, 7, 8, or 9 in first spot because my numbers are less than 600. So the numbers here are a 5. So 5 times 10 is 50, times 5, I have 250 possible numbers. Next one, find the number of, let's highlight what's important here. This one only has 2 digits, so right away. Counting numbers that are less than 90, such that both digits are even. So less than 90 means that the highest one could be 88, right? Because both of them are even. So pay attention to what numbers can go here. Sorry, that was my computer's way of reminding me that I have a Google Meets in like 10 minutes. So hopefully we get through this before then. All right, so it says both digits are even. So what could go here? 2, 4, 6, and 8. So that's 1, 2, 3. I have 4 options here. What could go here? 2, 4, 6, 8, but also 0, right? The number 90 is even. So I have 5 here. So 4 times 5 is 20 possible outcomes. All right, you have quite a few homework problems like this, hint, hint. So let's work this out. I have 5 history books. So history, I have 5. 1, 2, 3, 4, 5. And multiply. I have 4 science books. How many permutations are possible? If the history books must be kept together, that's why I put them all together, and the science books must be kept together. And if I have 5 different books, you physically can't put one book in 2 different places, right? So there's no repetition here. So I have 5 history books to put here, right, to choose from. Here I only have 4 books to choose from, then 3, then 2, then 1. And means to multiply. I have 4 science books. So I have 4 that I could put first. I have 3 left, then 2, then 1. So another way to do this would be to do 5 factorial times 4 factorial, which gives me 2,880. Now, it didn't say that history books have to come first. So I could put science first and then history, which would be 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2. And we already know what that answer is. Notice I just switched the order Okay, but we know that in multiplication order doesn't matter. So this is if I put the history books first. This is if I put the science books first. That would still give me 2,880. And I would add them. This would be if history's first plus the option if I put science first gives me a total of 5,760 ways I could organize my books. You will see that on your homework, so use this example. All right, 3 more. How many different 4-digit, so right away, set it up. 1, 2, 3, 4. Odd counting numbers can be formed if no repetition of digits is permitted. So remember, when it comes to doing odd or even, do the last digit first, because it's the last digit that determines if a number is odd or even. So numbers that could go here to make it odd, right, are 1, 3, 5, 7, 9. So there are 5. All right, now this says no repetition is permitted. So the second one I'm going to do is here. Numbers 1 through 9 could go here. But since I already used it, since repetition is not allowed, instead of there being 9, I'm only allowed 8 because I could have possibly used one of these already. Okay, so I'm going to do that one next. And then what would be left here? So let's say of these, I have 10 digits total. Or I should put, I have 10, right? I have these numbers to work from. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 possible numbers. Here I could only use these 5, 1, 3, 5, 7, 9. Here, if let's say I use 9, I still have 1, 2, 3, 4, 5, 6, 7, 8. I have 9 numbers, but I can't put a 0 there. So I'm only left with 8. In this next one, I could use numbers as 0 through 9, but let's say I've already used 2 of them. I'm only left with 8 because I've already used up 2 digits. Now I've used up 1, 2, 3 digits, so I should only have 7 left over. So there's a lot of thinking that comes into here. 8 times 8 times 7 times 5, I got 2,240. Okay. Next, an elf, a gnome, and this is, again, very similar to homework. An elf, a gnome, so an elf, a gnome, a fairy, a pixie, and a leprechaun want to sit in a line. How many different ways can they sit if, so notice I only use the E, the G, the F, the P, the L. How many ways can they sit if the elf and the gnome insist on sitting next to each other? Okay, so let's say the elf and the gnome sit first. There's 5 of them, right? What if the elf and the gnome sit here? So I'm doing all the different possibilities. What if, these are my 5 chairs. Okay, I have 5 people. So 5 spots. So what if in my 5 spots the elf and the gnome sit here? Okay, what if my elf and my gnome sit last? So if I was to fill in these spots, if the elf and the gnome sit here, then I'm only left with 3, then 2, then 1, 3, then 2, then 1. 3 could sit here, 2 could sit here, 1 could sit here. 3 times 2 times 1. All of these equal 6. So that's 24. Anyone seen another possibility? Doesn't say the elf has to sit first. Or, right, it could be gnome and then the elf. And then 3, 2, 1. Right? And then I could just keep moving this around to look like the others. And we already know what all of these are, but if you're looking at my notes and you don't see how I got everything, whoops. So this is in the case if elf sits on the left. This is the case that elf sits on the right. And each of these still gives me 6. So I have a total of 48 ways. All right, I have a Google Meets in 3 minutes. So let's see if we can do this last one in 3 minutes. How many ways can the following digits, make sure you get all of them, be arranged in a row of 3 to form an even counting number? If repetition is permitted, 7 cannot be second and 4 cannot be third. Whew, there is a lot going on here, right? So I have a row of 3. Let's talk about the first thing. Repetition is permitted. 7, so I cannot put 7 here, and 4 cannot be third. And so what could go here? 4, 5, 6, 7, 8, and 9. So 6. How many could go here? Well, everything but 7, right? So 4, 5, 6, 8, and 9. So that's 5. Now this says even. So the only thing that could go here is 6 and 8 because even number. So that would give me 60 total options. 45.B, we skip. It's 2-variable analysis, linear regression, and that sort of thing, and we're not going to do that. So for homework 45, you will be skipping number 3, 5, 8, 9, 21, 23, and 28 through 30. A lot, but that's because we skipped lesson 44. Thank you.